So, have you ever just stared up at the sky and thought, where does it all stop? You know, is there a wall at the end of everything? It's one of the biggest, most mind-bending questions you can possibly ask. And let me tell you, the answer is going to stretch your brain.
Okay, so let's just jump right in with a real head-scratcher, a puzzle that seems to completely break physics. We know the universe is about 13.8 billion years old, and we know nothing can travel faster than light. So, shouldn't the universe be, at most, 13.8 billion light-years across? How on earth do we get a number like 93 billion? It just doesn't add up, right?
Well, to solve this riddle, we have to kind of rethink everything we thought we knew about distance and movement. And the answer, well, it doesn't just bend your mind. It's going to completely change how you look at the entire cosmos. And here it is. This is the secret. Einstein's famous speed limit, it only applies to things moving through space. But space itself, the actual fabric of the universe, it has no speed limit. It can stretch, and boy, has it been stretching since the very beginning.
Okay, here's the best way to picture it. Think of galaxies as little raisins inside a big lump of bread dough. Now, you stick that dough in the oven. As it bakes, the dough expands, and all the raisins get pushed further and further apart from each other. But here's the thing. Are the raisins actually walking through the dough? No, of course not. The dough itself, the space between them, is expanding and carrying them along for the ride. And folks, that is exactly what our universe is doing.
All right, so keeping that raisin bread idea in our heads, let's see exactly how this whole stretching space thing solves that crazy 93 billion light-year problem.
To even talk about this properly, we need a new kind of ruler, a cosmic one. Cosmologists call it co-moving distance. Now, this isn't just about how long a beam of light traveled to get to us. No, this tells us where the thing that sent that light is located right now, today, after all that cosmic stretching has happened.
So picture this. A photon of light leaves a galaxy way back at the dawn of time. It's zipping towards us at the speed of light for 13.8 billion years. But while it's on that epic journey, the very space it's traveling through is stretching out like a treadmill that's getting longer and longer every second. So by the time that little photon finally gets to us, its starting point has been carried way, way farther away.
So how much farther away are we talking? A mind-boggling 46.5 billion light-years. That's the co-moving distance to the edge of what we can see. That's the radius. So you double that for the diameter, and what do you get? 93 billion light-years. And just like that, paradox solved. But, solving one question just leads to another. What even is this oldest light? What are we actually seeing at the very edge of everything we can see?
You might think we can just look all the way back to the Big Bang itself, but we can't. For the first 380,000 years, the universe was basically a super hot, soupy, glowing fog. Light couldn't go anywhere. It was just trapped, bouncing around. The edge of what we can see is the exact moment that fog finally cleared, when the universe cooled down and all that trapped light was set free for the first time. We see that ancient light today as a faint glow all around us called the cosmic microwave background.
So there you have it, our own little observable bubble, 93 billion light-years wide. But, and you knew there was a but, this is where things get really strange. It turns out the edge of what we can see isn't the only edge that actually matters.
Yeah, it turns out our cosmic horizon isn't just one single line. It's more like a set of those nested Russian dolls. Each layer defines a different kind of limit, what we can see now, what we could touch, and what we might see one day billions of years from now. Take a look at this. This map really lays out our true cosmic limits. It's not one bubble, it's a whole series of them, and each one has a really profound meaning for us. So let's break down what these layers really are.
Okay, let's walk through this. That smallest bubble, the effectable universe, is everything we could ever physically reach or influence, even if we traveled at the speed of light. It's only 16.5 billion light-years away. Then you have the one we just talked about, the currently observable universe at 46.4 billion light-years. But beyond that is the eventually observable universe, galaxies whose light hasn't even reached us yet, but it will someday. And that biggest bubble? That's what we could see if we could somehow travel to the very edge of our effectable universe and look out from there.
Now think about what this really means. This is the part that just blows my mind. We can see things we can never, ever touch. Because our effectable universe is so much smaller than our observable universe, it means the vast majority of the galaxies we see in our telescopes are already racing away from us so fast that we are causally cut off from them forever. They're like cosmic ghosts. We can see their light, but they are completely and forever beyond our grasp.
Okay, so if there are all these different horizons, all these different edges, then what is the true edge of the universe? I mean, does it even have one?
Probably the best way to think about it is like the fog of war in a video game. You know how the map is huge, maybe even infinite, but you can only see the little part you've explored? That's our universe. The edge isn't a brick wall. It's just an information boundary. It's simply the point beyond which light hasn't had enough time to reach us yet. The universe almost certainly just keeps going.
And this all boils down to one of the most fundamental rules of physics, cause and effect. To get information from something, you have to have a causal connection to it. If a galaxy is so far away that its light can never reach us, and we can never reach it, then for all intents and purposes, it's not part of our reality. We simply can't know anything about it. And if you want one more dose of humility here, remember that even inside this tiny bubble that we can see, we only understand about 5% of it. That's the normal matter. All the rest is the total mystery of dark matter and dark energy, the very things that are driving this whole expansion in the first place.
So in the end, the universe probably doesn't have an edge. It doesn't stop. But our ability to see it, our ability to touch it, and our ability to know it, that does. And that leaves us with the biggest question of all. If our entire observable universe is just one tiny, insignificant patch in a cosmos that could be infinite, what else is out there, hiding in the dark?